All right, let's look at angles. So some terminology. An angle would start with a vertex, and then we have an initial side and a terminal side. And this measurement in there would be the angle. And so we can go in a positive direction, that is counterclockwise. And we can also go in a negative direction, which would be clockwise. So our angles, if we put them into the coordinate system and we had our angle where the vertex is at the origin, then we could have angles lie anywhere in these 4 quadrants, and then we could also have angles like a 90-degree angle. That terminal side would be exactly the y-axis. So we can measure angles with degrees, and just like a number like 0.5 can be written as a half, so angles in degrees can be written with a little bit more precision, and we'll use minutes and seconds, and it's a lot like working with time and a clock. So 1 minute, so if there's 360 degrees all the way around, that's 1 full rotation. So if we looked, it's hard to draw because they're so little, but if we looked at 1 little degree, and then we split even that, if we really zoomed in and split that into 60 segments, 1/60th of a degree is what we call a minute. And then 1/60th of that is what we call a second. All right, so if we're trying to be extremely exact, like for example, sending a rocket to Mars or something where one even tiny fraction of a degree would make a big difference in where we would end up in the universe, then we need this idea of minutes and seconds. Okay, so I'm going to convert 74 degrees, 8 minutes, 14 seconds into a decimal degree. So 74, that's already in degrees, so we're good to go. But 8 minutes, that is 1 degree is the same thing as 60 minutes. And so if we're trying to convert, we would, just multiply by a unit fraction there. Our minutes would cancel out and we'd be left with degrees. So basically, you just take your minutes over 60, and that's how you convert that to degrees. And then we are going to do the same thing, same idea for our seconds, okay, because 1 degree is the same thing as 3,600 seconds. Then we would just multiply that by that unit fraction there. And so that's, if we would multiply, our fractions here, we would get 8 over 60, converting minutes to degrees, and 14 over 3,600, converting our seconds to degrees. Okay, and then we just add all that together to get our decimal degrees. Now going backwards is a little bit harder. So let me just show you. So if we're trying to convert 34.817 degrees into minutes and seconds, what we need to do is take our decimal component of our degrees and then just figure out how many full minutes would be equivalent to that decimal. So we multiply our decimal by 60 because that's how many minutes there are in a degree. Okay, when we do that, what we get, this section right in here, is 49.02. So that tells us it's 49.02 minutes. We just converted 0.817 degrees into minutes. Okay, but now I still have a decimal of minutes. Okay, so I need to take that decimal and multiply it by how many seconds there are in a minute. And we get 1.2. Okay, so then that would be the total seconds. All right, so every time you get a decimal, then you would just multiply by the next smaller part. So if we're going from decimal degrees to minutes, we multiply by 60. And then if we're going decimal minutes to seconds, we multiply by another 60 until we're done. Now some calculators have this button DMS, which allows you to convert from decimal degrees into degrees, minutes, and seconds. All right, let's look at this idea of a coterminal angle. That just means two angles that end up in the same spot. So for example, you see that 60 degrees, if I drew that, I would get a terminal side of my angle right here in quadrant 1. Now, if I measured out 420 degrees, I would end up with the exact same terminal side. Okay, so coterminal means they have the same terminal side. So let's look at, find the angles of smallest possible positive measure for each angle. Well, first of all, let's just see where 908 degrees is. So I go around once, that's 360. I go around a second time, that's another 360. So that would be 720. Okay, but I haven't gotten to my angle yet. So if I take 908 and subtract 2 full rotations, which is 720, I get 188 degrees. Okay, so I need to go an additional 188. Remember that going halfway around is 180 degrees. And so keep going another 8 degrees, and we're approximately right here in quadrant 1, 2, 3. Okay, so that is 908 degrees. Okay, so what's the other way of getting there? Well, just go straight 188 degrees. So these two angles are coterminal, 908 and 188, because they end up with the same terminal side. Okay, we'll try another one, negative 75 degrees. All right, so negative 75, it's negative, so I need to be going in the clockwise direction. A quarter of a turn is 90 degrees, so there's negative 90, so 75 I wouldn't have quite gotten there. So I'm just going to kind of approximate that. That is negative 75 degrees. All right, well, another way to get there is to go in the positive direction. Okay, so since an entire rotation is 360, okay, then if I subtract that 75 degrees, I get 285, which would be the direction I would need to go in the positive degree. So 285 would be coterminal with negative 750. So if we're trying to kind of expand that to give an expression that generates any coterminal angle with 135, well, first of all, let's figure out where 135 is. Halfway across or around an entire rotation is 180. This is 90. Half of 90, this would be 45 degrees right around here. And 90 plus another 45, this is 135. Okay, so coming all the way here, that is 135. Now, I could go an additional full rotation. One full rotation, that's at plus 2, that's, plus 360 degrees. I could go another 360. That just gets me all the way around. One full rotation is 360 degrees. Okay, so a general way of writing this, I could take that 135 and add 360, well, any multiple actually of 360, so times some n, where n represents any integer. So it's just any multiple of 360.